Hi guys, David here from Almost Daily Science. So today we're going to talk about polyethylene, the most abundantly manufactured plastic on the planet. And specifically what we want to get to the bottom of is if it's possible to make a version of polyethylene that will be more biodegradable or able to break down in the environment instead of persisting indefinitely. So we're looking at an article brief with the title New Kind of Polyethylene, Durable Yet Degradable. And what this is looking at is research from the University of Konstanz, and what they've done is actually make a type of polyethylene that has incorporated within its chain carbon monoxide. And this is not new in and of itself. Actually has been well known that carbon monoxide and ethylene, which is the subunit for the polymer polyethylene, can actually copolymerize together. But what they're doing here is trying to balance the way that it's polymerized in such a way that it would be feasible to scale up, would still have the good mechanical properties of polyethylene, and then finally has more degradability than normal polyethylene. But what is polyethylene? Well, there are a number of ways to answer this question, but probably the first and best way is to answer it as a chemist. And so what we're looking here is actually at a chemical structure of polyethylene, and you can see that there are brackets shown here. This indicates that this orange colored part of the molecule is actually repeated over and over and over again, and what you end up getting is basically a long string of carbon atoms which each of them have two hydrogen atoms. And that is simply what the chemical structure of polyethylene is. Probably more to the point for most of us, polyethylene is, according to Wikipedia, the most common plastic in use today. It is a polymer primarily used for packaging, plastic bags, plastic films, geomembranes, and containers, including bottles. As of 2017, over 100 million tons of polyethylene resins are being produced annually, accounting for 34% of the total plastics market. So when you're thinking about plastics and when you're thinking about plastic pollution, polyethylene is a major player. And when you look into it, you can understand why. Polyethylene is really easy to work with, and you can do all kinds of things in terms of shaping it and molding it. And so looking at a website here, this is Chevron, Phillips chemicals. So this is definitely a pro plastic website. They're showing all the wonderful things you can do with it. There's blow molding, injection molding, conduit and pipe. You can make high strength resins, including bimodal PE 100 resins, ideal for industrial applications, or crack resistant is critical. Obviously film coating and laminating, so polyethylene films have a wide range of applications from food packaging to protective coating and laminations. You can extrude it into large sheets to make flat plastic sheets. You can do rotational molding, which I don't know a whole lot about, but apparently it is maybe what you use to make something like a plastic boat, a kayak, for instance. And so polyethylene is popular for very good reasons. You can do many, many things with it. And those uses show up in our day-to-day lives. So polyethylene is produced by the polymerization of ethylene, which is a small molecule depicted here, which is shown as two carbon atoms with a double bond between them, and then they each have two hydrogen atoms. And ethylene is a very common byproduct from the oil processing industry. So it's very, very abundant, and that's partly what makes polyethylene so affordable. So what we're looking at here is basically the question again is, can you make a version of polyethylene that has all these benefits of polyethylene, like the easy processing and the low cost, but is able to degrade better? Because polyethylene is not particularly biodegradable. What researchers have found is that if they polymerize the ethylene in the presence of a small amount of carbon monoxide with the right catalyst, they can actually develop an alternative structure that has groups that can actually degrade. Not actually biodegrade, but they can degrade from a mechanism called photodegradation. And the way this works is if the reaction is successful, what you get is a structure which is mostly polyethylene, but it has a certain number of what are called ketone groups. And you can see this depicted here. This is a polyethylene molecule which has a couple of ketone groups. And these ketone groups are depicted as, you have here the black line is the carbon backbone, and now what we have is a double bond to an oxygen molecule. And this group in particular is susceptible to photodegradation. So one of the articles that I found on the subject says, in-chain keto groups are particularly well suited to promote photodegradation as they enable chain scission, which means that the long chain of the polymer will actually end up getting cut right there at the location of the keto group. And then what you have is, instead of a very long polymer that is essentially very, very hard for nature to break down, you have short hydrocarbons. And nature has developed mechanisms much more common to be able to break down this type of molecule. So for instance, there are all kinds of bacteria which can do that job, though they are perhaps not as ubiquitous as you would hope. So as I mentioned before, the idea of copolymerizing ethylene and carbon monoxide is not really novel in and of itself, but the issue is that when you do this reaction, it tends to be that the ethylene groups and the carbon monoxide groups like to polymerize in an alternating format, which means that you have basically they go every other. So that's the way the chemistry works with normal catalysts, is you wind up with an ethylene group and then a ketone group, ethylene group, ketone group, ethylene group, ketone group. And it ends up being that a polymer like that, which has this very rich quantity of carbon monoxide in it, tends to not really be polyethylene anymore. It doesn't have those blow molding properties, and it just lacks the mechanical properties that make polyethylene so good. And so what the main focus of this new research is they actually work to develop a specialized catalyst that would help them to, instead of making an alternating copolymer with ethylene and carbon monoxide, they were able to make a copolymer that had just a little bit of carbon monoxide kind of sprinkled in there at specific locations, kind of spaced out. And that meant that the vast majority of the polymer was still just plain old polyethylene, which means it still had the mechanical properties they were looking for, but it still had those groups in there enough that were photodegradable, that the overall material was much easier to degrade. So the article says a key factor in this process is creating just a limited amount of keto groups in order to maintain typical and favorable mechanical properties of polyethylene, like durability. Now they said after this, they actually went ahead and on a laboratory scale demonstrated that when exposed to simulated sunlight, the new plastic displays a slow chain degradation which does not occur at conventional polyethylenes. So that's very cool. So if you can picture maybe a plastic bottle which is made out of this improved version of polyethylene, and then you can picture that plastic bottle maybe bobbing about in the ocean, being exposed to sunlight, there's maybe hope that such a material would actually be able to degrade under those conditions, and then eventually break into smaller hydrocarbons that could hopefully be essentially eaten and chewed up by bacteria in the ocean. That being said, since it is actually a sunlight-driven mechanism, you could see that this is not really a silver bullet when it comes to plastic materials which wind up in a landfill, because assuming, as you normally do with a landfill, that the majority of the material, instead of being sort of exposed to the surface, actually gets buried down in the earth, the plastic would not be exposed to sunlight. So I don't really think this is kind of as big a deal as I initially thought when reading these articles, but still it's an improvement. And I hope that if they can roll this out, this could mean that if plastic bottles, for instance, or drink containers of any sort wound up in the ocean or on a beach somewhere or just out in nature, if they were actually exposed to sunlight, they would be able to degrade. Well, I've included a link to this article as well as a link to a scientific article about the same topic. And if you're curious, I encourage you to dig deeper. And if not, I hope you have a great day. I want to thank you so much for watching, and I hope you'll join me again in the future soon. Bye.